to welcome you back to our last session of the day. Of course, our last speaker needs no introduction. He is, as I said earlier on this morning, or this afternoon rather, probably the amateur lunar scientist in this country. He's the VA president this year, and he's going to talk to us this evening about the Lunar Crater Thebit. Patrick Moore.
Yeah. Yes, come on. So let's see if we'll set up. No, it's fine. It's not a declaration. It's on the right down, too. I'm going to show the slide. Well, ladies and gentlemen, I really want to emphasize certain what I was going to talk about, because we had three very fine reports to say, after the war, no trade comes to that stuff. I will do my best. If I don't mind, I'm slightly outrageous at times, and I'm quite aware that in some respects my views are not quite the same as those of many other people. So I want to begin, if I may, by showing you a picture, which you all know. I've gone too far, I'll do it again. And that is not, in fact, a picture, but you may think this is not. We'll take that as quite right. Then is a drawing by one of our great lunar artists, Frederick Ball. So Berkeley has been making lunar observations now for a great many years, and I'm delighted to say he's still going strong. And that is one of those typical lunar drawings. And 2 years ago, you might try to do things in a photograph. Well, that reinforces, I think, what I said earlier on. You get people like Berkeley, and some of these people we're going to see tonight, which will be exactly like the lunar surface. But if you're not an artist, and I'm not, and there's an artistic person in 2 continents, it still doesn't matter very much, because you can still make drawings that are used for an actor, even though they won't look like that. But I told you this for 2 reasons, mainly. You will recognize, of course, the general area. That is called a straight wall, and it's called that because it is not straight and it's not a wall. It is, in fact, a fault in the surface, and if you are standing there looking in that direction, you appear to an 800-foot rise, and from there looking in that direction, you appear to an 800-foot drop. And going back to the book written in the early part of the century, that's pre-1940 or so, you will find that was said to be almost perpendicular. But it's not, in fact. And that was a study of measurement made by Gilbert Field and myself way back in 1940-41, I think it was, a long time ago anywhere. And we determined that into the shadow, and we found that the actual stroke there was about 40 degrees, so it was just about to scramble up it. But it was the only fault at the time like that on the moon. There are plenty of faults, of course, but none that are quite so extensive as that. But next to the little crater there called Earth, which is at the top of the world, and those rings there, those are unofficially known as flagpole mountains. But I'd like to note, I'll tell you about this later, that the straight wall itself part of the arrow forms a major axis of a very large ghost ring. See it there quite clearly, and when I see the pictures, I think you'll realize what I mean. It is in fact the axis of a large ring, which makes it significant. And there is the paper I really want to talk about, and that is Thebit. Thebit A, and Thebit B. And the whole cornerstone, what I want to say during the next 40 minutes or so, and I'm not going to go on longer than that because I don't have the way to run, is the fact that we have there an absolutely typical arrangement of interrupting craters. You have the small Thebit A interrupting Thebit A, and you have Thebit A interrupting Thebit itself. Smaller and larger, smaller and larger. And that is the case in 99.9999 of all the instances of where one crater interrupts another. I remember a program we did in the lunar section, and when was it? 1955, 56? And we did an overlap crater program, and we searched around to see whether there were any exceptions to that rule. And there are very, very few. Now, at that stage, I introduced, there's another picture, and I put it upside down, and maybe the wrong, never mind. I should explain that the picture I'm going to show have got 12 at the top. Because I'm an old-fashioned lunar observer, and until the edict of the 1950s and the International Astronomical Union, east from the south of the top, and east to east and west to west. There was then a gap in Commission 16. I went to defense in the south of the top, and Mari Kreising where it should be, and I was overwhelmingly defeated. And therefore, now we have north of the top, and the Mari Kreising, which was on the west, is now on the east, or is it the other way around? Anyway, as far as I'm concerned, I have to stand on my head, so I have to do that one. So the point of fact, what I'm going to do is stick to what I know best, south of the top. This one's on north of the top, and so we have this label as well. There again we have these straight walls and the straight wall numbers. Note this time the straight wall here is a bright line because it's after the full moon, and of course the sun is now shining on you in the meditation. Then it's again with the birthday just interrupting the wall there. There is the birthday, really a face change, and there again is Felix. You can see that structure very clearly. And what I would like you to notice, because I'm going to come back to this over and over again, is that where one crater interrupts another, first of all, it's the smaller and the larger at the time, and secondly, the wall of the crater, which is broken by the smaller formation, is absolutely perfect right up to the point of junction. You see the wall through the there. It comes down in loop-seated areas. Even a wall is perfect, right up to the point where it is interrupted by cubic trees. There is no area of shaking down or ruining. And of course the lunar surface is very much less rigid than iron, and we know that with the shaky irregulars there. And I think it's quite inescapable that if those formations were produced by a really violent origin, then you could not have that kind of thing at all. There's certainly an area of shaking down where the second phase will appear. For example, if that's produced by a meteorite falling on the wall of the originally existing crater, then it certainly wouldn't leave the wall perfect right up to the point of junction. And I'll give you examples of that later when I show some earth volcanoes. And I think that's a very important point to make. Also, that the arrangement of the little crater has pairs, trios. There's nothing really random about it. And this system of non-random distribution is, I think, influenced by Thebit itself. And I told you that, and I gave that the title of my talk, which is so absolutely typical and probably the best case of its kind. Now, there is our two drawings. The Thebit group, and that was a rough sketch I made from observation in 1954, when 18 in the course of Professor. And I can tell you who the Professor that was Harry Thornton. How many people here remember Harry Thornton? Northern. Yes, you probably do. Well, Harry's now well in his 90s. He was the editor of the journal Period of the Moon, which preceded the New Moon, and he was a very fine observer in his own right, had a very fine 18.5 inch, lived in Norfolk. And of course he got in effect during observation now, because how old was Harry, 93, 94, something like that. But he was a great man, still is. And I made that with his criticism. And I just say, there was another step, and I couldn't do it from a direct observation, but you don't find it. That kind of thing you don't find on the moon. Now, when I said that, when I mentioned it before, I labeled that forms never found upon the moon. That is not absolutely true. I've got one or two. When you're talking about one or two, and you're dealing with tens of thousands of cases, which you are, it isn't very much. And there's nothing so random about that. So let us move on. Here again, we have another case. This time I know it's in the middle line. I want to have a failure. And there is failure. The failure is one below, doesn't matter. And we have a line of failure this time, as you can see, forming part of the old part of the wall. If you look closely, and I'm afraid you can't actually see it on this side from there, you see smaller scale, you'll see the wall of failure actually being continued through failure phase, an interlocking failure. And again, that shows that if you can't have that kind of thing, produced by a very violent bombardment. There's Thebit down at the bottom, there's this huge Thebit, and there's the straight wall, and there is Cyprus, which of course takes the form of a bay, with seaward walls pretty well leveled, and the actual connection there between it and the outer country. And there we get another one I thought I'd show you. Again, I'm afraid Thebit got off this one. I looked for an orbital view, this is more than an orbital picture, showing Thebit. And the only one I had didn't show very well, but I thought I'd show the straight wall anyway. But it does bring out that ghost ring clearly, as you can see. There's a test down there, and there's the case of dirt, and you can see it again, and there is the dirt test. And if you look at that, you will see that that is not really a test score. It's very expensive to explain. It's because the Dr. Wilson was talking about this morning. It actually begins in a kind of a bowl or a small crater, and it runs down and the shape like a nozzle, which also ends in a small crater. And that is what one of the early areas studied by the authors, and it gives us a pretty good idea of one of the relatively smooth parts of the moon. So once again, you see that I was dealing all the time with non-random distribution. Look at that. Another area, this you'll recognize again, this is the Hydrangos test. And you can see that very easily with a very small telescope. And just to give you an idea of scale, you probably all know it anyway, there's Hydrangos, of course, as you is 4 miles in diameter. Up there we have some sediments, yes, I'll show you in a minute. But there's nothing very chest-like about that. It's just crater-like enlargement all the way along. And no matter what you think about the general origin of lunar craters, I don't think anyone can really maintain that that's true by impact. Somebody once said, to fall in that way, I think it's one viewer who said it, they'll have to be very educated meteorite. In fact, the more you look at these very, very depressed or riddles, the more of them do actually turn out to be crater shapes, which is rather interesting. They're not all, but many of them are. And that's the case in point. Then you have the very much more obvious ones. Here we have the real area of Capella. You recognize here the Gutenberg. You have the crater things there, and they're part of the crest system, which we all know. And there's a fairly typical example of a crowded lunar area. And once again, you have pairs of craters. Here's Capella, and if you look very carefully, you can probably just see there is a funny crater. And many of these craters, Camps, another, Albuquerque, which has occurred, many of these have got summit tips on them. Now, remember in Baldwin's original book, way back in 1950, I think it was, when he was calculating the number of summit tips that were distributed upon lunar mountains by sheer chance, he worked out that there should be about 8. And at that time, I think 7 were known, and he said that the agreement is excellent, and the meteoric theory is corresponding to strengthen. And that's why I went out to Mergon Observatory, and I was let this on the 33th Mergon refractor, and over a period of 3 durations, I found another 74. Hardly to explain, the bomb doesn't fall into the bucket every time. Now let's turn to the other side of the moon, and there's the area of Hale and Schrodinger, and this of course is one of the early orbits of there. And you can see there that we're closing the valley, which again we've got crater-like enlargement all the way along it. Rather interesting, you know, we've got detailed pictures of that one now. Here's another area, taken near Hale and Schrodinger again, this is very well seen there, and these places are kind of ponded surfaces. Rather interesting, the only people who have actually seen those at first hand are the people of Apollo 8, 10, 11, 12, and 13, 14, 15, 17, Apollo 8 and 10 to 17 inclusive. And they're the only people who have actually seen those direct. It's rather amazing you have now such detailed maps of all the areas of the moon we can't actually see. Although, as Dr. Wilson said, there are 1 or 2 areas, particularly near the South Pole, that are not well mapped yet, though they were missed by the orbiters and by the Apollos. And the Russian pictures, which do cover it, are not nearly so good. So there is still scope for little lunar mapping near those areas. What is jolly difficult to do is this so-called problem. But the lunar mapping is not quite over yet. Sheer cartography is still useful, even though, of course, when I first joined the lunar section, I was going back down to 1934, what we were doing there was to draw a chart of the moon. Now that's all been superseded. There is a fact that right up to the page when space travel took over, the best not chart of the moon were the other one. No question about that. The International Astronomical Union did produce an official map in 1933, and thank you, it is what we do not use. There's another lovely picture. You recognize that as the Crater Valley. Okay, Crater Valley was a bad name for it. I know it's supposed to discover it, but the Crater Crater is right on the way across the moon, nowhere near the valley at all. People call it Herodotus Valley, I think. Anyway, there it is, a lovely winding link you all see. And I thought you might like to see that picture. It is one of those, it doesn't really publicize very much. And there is an area of peacemaker. Can we stop touching just a little like this? Because this is rather interesting. Now, there is peacemaker itself, and there is the system of peacemaker tests. And these are not the same in nature as many of the others I've been showing you. Because, as you can see, in many cases they are genuine tests. They give the general impression of being cracked in dried mud. I'm not sure if there's any real analogy there, but there is definitely a difference between those and the very obvious crater field I've been showing you before. And that crater field was theory put forward in the 1950s by Dr. Thomas Gold. And he suggested that the lunar maria was filled with very soft dust, and that therefore, in his own words, any spacecraft landing there would simply sink into the dust with all its gear. Thus, the long and dangerous journey through space would be rather disappointing. Well, it didn't really easy to hold up, but there is reason. First of all, look at a crater like Archimedes, for example. His theory was that the dust flowed downhill until it reached the area of lowest potential energy where it piled up. therefore it has flowed down into the bottom of the circular maria, and there it has accumulated. But as I pointed out, inside Archimedes you have exactly the same texture as you do outside, and therefore, presumably, the same stuff is invaded Archimedes, and to get there, it must have got to the wall and then flowed uphill, using the right shape. But more carrying stones, and if you look very closely at the bottom of these steps, you can see, their walls are bright. And of course, on the gold theory, those walls were in dark. And I've never quite understood how that theory was so widely accepted for so long. It was. In America, it was quite flat. It wasn't finally disproved until Lunar 9 actually landed on the surface and showed no sign of going into it. I think that just proves that although many astronomers are brilliant in the field of mathematics and astrophysics, if they're going to talk about the moon, they do look at it first. There was another picture, and I thought you might like to see that one, and that again is the area of Peacemaker. Now, is that a drawing or is it a photograph? Anyone any ideas? It's a plaster model made by no person James Naismith. Naismith and Carpenter, who wrote the first really good English book about the moon, was published in 1874, with the moon and the conditions and configuration of its surface by James Naismith and James Carpenter. Naismith also invented the steam hammer. And if you want to see his telescope, you'll find it in the Science Museum. And I always think it's a wicked shame that it should be there, because it's the first usable telescope. Anyway, Naismith was a great man making plaster models, and in his book, he produced several of these. I think you might like to see one, because it is remarkably realistic. The book itself is great fun to read. They produced a theory of the origin of the craters, which does not stand up to examination. On that theory, a volcano was spouting out material and depositing it in a ring, and the wall was therefore built up from material showered out from the central vent. Because you can prove that straight away, because in no case does the wall of a lunar crater reach the height of the central mountain. That's one reason why it doesn't work. There are plenty of others also. So although their theory was wrong, it did give observation of the moon a tremendous boost, particularly as Neeson's great book came out at that same time. Anyway, there is one of the parts of the model, and here shows these tests as tests. And when you look at those, they are incredibly interesting. And in spite of the order pictures, I still think there's, as Dr. Wilson was saying, there's still a lot of work to be done when you study the actual ways in which these things cross each other. And you can get some very good idea of chronology there. And believe me, it's not nearly so straightforward as you might imagine. And when you start doing this, you start getting into a terrible tangle, because it doesn't really make sense. I'm quite sure it does make sense, but you have to look at it very carefully, and it's worth doing. So that's one thing I would suggest to the cartography section in the new moon. It would very worthwhile having a look at system of crests like Peacemaker, and the birth system, and the Hippolyte system, 1, 2 like that, and paying special attention to the ways in which these overlap. And you'll find very interesting things which have not really been brought out yet. I'm not going to reveal anything that makes sense of them somehow. There is another example, I think you all recognize that, and there, of course, is the famous Alpine Valley. Baldwin originally suggested that might be due to a meteorite striking its way through the rocks. Well, that is certainly not on. You can see that just by looking at it. And right down the middle, you can see a long, winding, rather narrow crest. Now, it was certainly thoroughly interesting because I discovered it. And that was one of the things I first alighted on when I went over to Merton around about 1952. Had a long, hard look with a 30-inch refractor, and I reported a crest running right down the middle of the Alpine Valley, and people said they would see it. But in point of fact, there it is. You'll also, if you look at just off the picture, find parallel valleys and also transverse valleys going in the same direction at right angles. And that really brings me on to the grid system, which again is highly relevant. And that was a system, two systems of formations aligned at roughly right angles, first pointed out by Spur and elaborated by Jonas Fielder. And a lot of doubt's been cast on the grid system, but when you try and chart the areas and find out the ways in which these things are aligned, I think you'll find the grid system where it does stand up to examination. It's certainly there, and this indicates what Dr. Wilson was saying, between compression and separation of the lunar surface. And that is a pretty difficult, rather rough area. Now, I think this is really outrageous. This is a picture I drew in 1959, and I have not redrawn it, because frankly I don't think I can improve on it now. I'm a rotten artist, that doesn't matter. What I've actually done there was to take all the formations, which are over 50 miles in diameter, or over more than 75 miles in diameter in dashed circles, and which were named on the original Gleason map. And of course we've got plenty of ghost rings, but those are the ones which are fairly well defined, and that picture does include all the formations which are 75 miles in diameter, and that is the limit. And or 75 miles in diameter and over. And as you can see, there's nothing very random about that. You've got your long chain here, the Fernarius, Petalius, Dendalinus, Langus, Mari, Chrysium, Endymion, Gilaldi, right down there. You've got the Great Western chain, you've got Bailey, Chicago, Grimaldi, Viteri, right down to Pythagoras. You've got the central chain down here, Delta, Regium, Montanus, Turdoxus, Alvecula, Alcombus, Ptolemaeus, and you've got a line down there. And if you look at that, I don't want to make anything random of it. And if you want to try and disprove the gift system, what I suggest you do is to turn your eyes round, look at this place, and you'll find that the alignments are still the same. That was one thing that Baldwin said in his book. When you said that the grid system is due to the fact that sun might come from the east or west, therefore casting significant shadows, and when you eliminate that effect, there's nothing much left in the grid system. Well, all you have to do is turn that at right angles, and you'll see it is wrong. And no matter how you look at it, the alignments are all the same. And the interesting thing is, me anyway, the alignments are very roughly, well not more roughly, they're pretty well lined up with the central meridian as seen from the Earth. Now there's the central meridian as seen from the Earth, and when you see this on a Mercator chart, it is very marked indeed. I didn't do it on a Mercator chart here because obviously you have the Greenland effect and therefore the sizes are distorted. But it is very marked. The main formations form huge chains which are lined up with the Earth's central meridian, centrally as seen from Earth. The other point too, of course, is there is a complete gradation from large chains like that down to the smaller chains of formations, right down to the smaller still, and then to the strings of beads which make up things such as the Hyginus crest. There is a complete gradation of sizes. But you will note here, I have included the Mari Humorum, the Mari Necklace, and the Mari Chrysium. Now, we come to this knotty point, and I hear I'm quite prepared to be shot at. Is there any basic difference between a regular Mari and a crater, except in size? And I have a very shrewd suspicion that there isn't. For example, consider, shall we say, Grimaldi. Then you're going to be too small there. Grimaldi is almost on the edge of the room. Put Grimaldi near the centre, and I have a sort of feeling it will be cast as a small sea. It's not very much smaller than the Mari Vaporum, and of course its area, its floor, is the darkest part of the moon, only occasionally rivaled by Plato. And I think we must admit that there's not very much difference. What we really want to do, of course, is to find a link between the craters and the seas. And can we do it? I believe now we can. Next slide, please. Oh, so. And there we have the Mari Chrysium. And this I put on because it does show the effect of foreshortening, so that it's clearly, because you might imagine the length that way is greater than the length that way. In point of fact, as you probably know, the Mari Chrysium is elongated, but its diameter east-west is slightly longer than the diameter north-south. So it goes to the highly deceptive. And I showed you that one particularly, that was taken when the vibration was decidedly unfavourable. And down there we do have one of the rare exceptions of our larger crater overlapping the smaller one. But as you can see, when you look at the interior of the Mari Chrysium, there's not all that difference between that and the interior of something like Grimaldi. And I suspect they're the same kind of formation. They've both gotten out into the borders. And also, note that none of the major seas, apart from the Mare Orientale, extend over onto the far side. I well remember the very first pictures I ever saw of the other side of the moon, because anybody ever saw, on October 26, 1959, when the Russians sent round Unit 3. And they had actually sent over, they did use the charts I had drawn of the moon to tie up the far side of the near side pictures, and they promised to send them over to me, and they did. And they actually arrived, and I just started doing a Skype night program live, and I heard the producer's voice in my ear. Pictures from the other side of the moon just come in, coming on your screen in 1 minute, scrap what we can, do it off the cuff, good luck. And by the grace of God, I recognise Mari Chrysium under reverse light, and I really think my hope is no special comment. The point is that none of the seas extend on the far side, apart from Mare Orientale, which I think was first seen by Wilkins and myself just after the war. We were drawing it at 15 inches, we were drawing the area at 15 inches, I said suddenly there was something on the limb here looked like a small sea, and we spent the rest of the night drawing it and sent in a report to the BAA, and we called it the Mali Orientale, or the Eastern Sea. And of course we had no idea then it would turn out to be a very vast and imposing formation. And you see, we called it Mali Orientale, the Eastern Sea, and thanks to the IAU decision, the Eastern Sea is now on the western limb of the North. The other Mali does not extend on the far side. You can't count Mali Australia, it's not the open sea at all. The Mali Moscoviense, well, that's not very much bigger than Grimaldi, and there isn't very, very much on the other side in the way of seas. I must, I think, show you this one. You all recognize. Well, I don't put the definition of that. Here's the sinus iodine, of course, taking my 15-inch telescope. Particularly very nice little paper pair. Once again, the kind of pairs you get all over the moon. There is the sinus iodine. You can just about detect what I suspect is an old wall there. It's there are isolated ridges and things. It's very nice here, but I think there's not much doubt that was a separate formation which had been invaded by the lava from the Mali Indian. Nothing quite like it on the moon. Of course, the jewel candle, you catch just one two illuminations for a couple of hours, and it really is the most magnificent sight. It's one of the loveliest sights anywhere on the moon, I think. But I was talking just then about a possible link between the craters and the Mali, and I think we found it. And here it is on the far side. And that, of course, is the crater Tsiolkovsky, named after the Russian father of space research. And of course, Tsiolkovsky, remember, was writing intelligently about the space research as long ago as 1895. And you may have come across a novel by him called Beyond the Planet Earth, written by Tsiolkovsky. It actually appeared in 1895. It appeared in English translation about 1960, I think. As a story and as a literary effort, it is atrocious. But as a scientific forecast, it really was decades ahead of its time. So when the Russians say that Tsiolkovsky had many of the answers, I think they're right. I think he has an honoured place in the history of space research. And just rambling en passant, the first great scientific treatise was written in 1923 by Hermann Oberth, and the rocket into interplanetary space, and it really started the entire thing off. And Oberth actually survived to see the launching of Apollo 11, and Oberth is still alive. I think he's now 102. I've only met him once. He speaks German, which I don't, so I couldn't talk to him direct. He doesn't very often appear in public life now, and I gather from a political point of view, he makes people like Hitler and Stalin look rather left-wing. He is still alive, so he's seen everything, right from the very start of it, right up to the men on the moon and even beyond. Anyway, there is the crater named after Tsiolkovsky, intruding into a larger formation of Earth, which you can see there. There is the outline of Earth, an unfilled one. And there is a very significant thing, because that is not shadow, that is dark lava, it's a lava lake, it's a big thing, 170 miles across, and it's got a central mountain. And if that on the near side of the moon, if it hadn't got a central mountain, it's somewhere near the main meridian of our side of the moon, I don't think there's any doubt that it would have been cast as a Mars. But it looks very like that. And there we have a rather nice picture. Once again, under more deep writing, there's the outer wall, terrace, there's the lava lake, there's the central structure. And as you can see, that does form, in my view, the missing link between craters and Maria. And I don't believe myself there's any difference between the two. And there is rather another lovely picture of it, and just about, there we are. Tsiolkovsky photographed by Apollo 15 camera, and this one's north is up. And there again, if you've got one of that very massive central block there. So, when I claim that there is a degradation between the large circular seas and the smaller circular seas like Trigon, right through the dark cold places like Grimaldi and Plato, down to the smaller ones, Billy and Hanstein, right down to the small dark cold places, I don't believe myself there's any real difference. And therefore, when we are talking about alignments, I think we've got to include the Maria with the craters, if we assume they're the same kind of formation. And then there are other oddities too. There, for example, the third round was part before, we recognize that. There is the famous shiver, that was in the third round, that's a compound formation. Another one there, here. Of course, these are all very on the limb, and they are all highly foreshortened, which is why mapping the moon's limb is such a very difficult process. That was one thing that exercised our mind very greatly for many, many years. And there, yet another of the Naismith models, rather a lucky one. You recognize that, Chicago, and there is Vargentin, the famous cat or cheese. And there's no doubt that that is simply a lava-filled crater. And however the crater was formed, there's no escape from the fact that lava welled up from inside the moon and literally covered it. There are, incidentally, other plateaus around. One of these small ones on the far side, but nothing as big as Sargentin, which is 56 miles in diameter. But I think you'll agree that another point I want to make here, that when you look at these pictures, the arrangement of craters is not quite the same as it is on the near side. There's a definite difference between the near and the far sides. You don't get anything on the far side, for example, quite so differently with Thebit. You don't get the same linear arrangement, although you do get long arcs of huge formations, some of which are unfilled with dark material. Well, Dr. Wilson did refer to this. I think myself, if you assume that the craters were produced by a random bombardment, I don't know how you're going to explain it. I certainly can't. If, on the other hand, we assume, and I think we're entitled to do, that the moon's rotation was captured from a very early period, so from a very early part of the Earth-Moon system, the moon has kept the same face towards us, then clearly the Earth's gravitational strains on the near and the far side are not going to be the same. And if you had lines of weakness, then they would naturally appear more or less along the central meridian as seen from Earth and parallel to it. And that's precisely what you get on the near side, which you do not get on the far side, which in my view is highly significant. Again, you come back once again to Thebit. There it is. You see that once again, large, smaller, smaller. If you look down, you won't see on that picture anything quite like Thebit, because it is such a particularly good example. But you will see plenty of cases of one crater interrupting another, and in every case, smaller into larger. Also, note craters like that, for example. Well, that's one let's go to the famous plateau, one of the most famous really placed on the moon, and that was landed in an area which is crowded with detail. Now, the rays from Tycho extend over all other formations, and therefore there's no escape at all from the fact that the Tycho rays are the youngest formations in that area. They are not overlaid by anything, they overlay everything, therefore they must be the youngest things. And therefore, and any impact theory, or most volcanic theories too, Tycho must have been the latest crater in that area. Not one of the latest, but actually the very latest. Well, can anyone explain to me how a missile can come down on a rather fragile lunar surface, blast down a 54-mile crater, and leave everything around it totally undisturbed? You tell me. Another picture, not really good one, I took myself. Again, I hope that it does just match up. There is Clavius again, and no, you can't see an unclear this definition, but there is just a continuation of the wall through Clavius A, which you just about see there. And we're going to have an arc-like line of craters, which surely does indicate disturbance, which petered out gradually and produce smaller and smaller craters until it became indistinguishable. On an impact theory, well, it doesn't have meteors landing very nicely. 1, 2, 3, 4, presumably at different times, I don't know. It doesn't really hold good at all. There is a better one, in fact, Clavius, but I knew that the shadow was unsuitable there. The wall does in fact go across the floor of Clavius A and Clavius B, towards water. But when that picture was taken, and I did not take that, when it was taken by Wilson, the shadows were unsuitable. But that's a pretty good example, I think, of another case of non-random distribution of craters. And the point I'm trying to make, starting the Thebit as my cornerstone, is that we have this non-random distribution the whole way through, which I think is very interesting and very significant. There, of course, where you all recognize those two, Ptolemaios and Alphonsus, with our castle above just out of the picture, and it was just in that area there that in 1958, Nikolai Kozyrev made the first, well, one of the first professional observations of a lunar transient, and certainly the first to obtain a spectrum. And you may not know that Kozyrev has died, which is very sad. He died a few months ago, most unfortunately. He was a great chap, Kozyrev. I think his interpretation of that particular transient was entirely wrong. He said he wanted to do the high temperature, and I'm quite sure there wasn't. And nevertheless, there was something there, all right. And subsequently, various people, including Brian Warner, who was then at the University of London Observatory, now director of the Cape Town Observatory, reported a red patch there, which I was never able to see. I looked for it, and Wilkins for it, but I didn't. I could never see that red patch, and I don't think it's there now. It was in there, I don't know. Anyhow, there it was. But there's another example, you see, the large chain of the craters, with the Ptolemaios is just slightly that up from Alphonsus, and it is slightly the larger of the two. Another case, here we have two of those famous wheels on the moon, There's the High-Venus Ring again, part of the peacemaker system, and there you see part of the Ariadeus Ring. I want to show you that to show the Caesar crater chain. Julius Caesar there, one of the smaller draft floor formations, and running down there you can see what is a very broad, very obvious crater chain. I'm afraid I'm not an able picture, there's another one of mine, but I didn't get it quite right. Nevertheless, there it is. If you look at Julius Caesar, I think you will see that. You also see there the famous spiral mountain, the Schneckenberg, which under a high magnification really is an incredible. You call it the Snail Mountain. And what about pairs of craters? Well, at the back there, you can very skillful drawings of Messier and Pickering, and there's one of my pictures of them. There is Messier, there's Pickering. Pickering down in the picture is WH as Messier A again. I don't know who named it WH Pickering, but it was named as that on many of the charts, but then the IAU dropped the name, and I called it Messier A. Okay, obviously we must follow their decree, but I don't think it was Pickering all the same. You know, there's Messier A. Beer and Madden are described as exactly alike, but they're not alike now, we know that. But they do show very strange optical changes according to the illumination, and there's not the slightest doubt in my view that they've changed at all. I mean, they do appear to show changes of shape and size, but actually they don't. But note there, you see, there's a comet ray which crosses the Mare and reaches the highlands there, and there are no rays in any other direction. So either the rays coming out in other directions have been obliterated, and I don't really see how that can have been so, or else they were really produced only in that one direction by some kind of asymmetrical blast, so to speak, which I think we've got again put down some kind of internal action. This is where it isn't be. Actually, H.H. Nininger, the famous American meteorist, he suggested there might be a tunnel connecting those two. I think a tunnel is not on, I'm afraid. It's not the idea, and I fear it's not so. Although, no doubt, in the far future, Messier and Messier A are going to be some of the lunar showpieces. Oh, Linné, just in passing, I don't want to bring the possibility of changes upon the moon. I am convinced now that there never have been any detectable structural changes, certainly not for about 1,000 million years. Linné, a classic case, described by Beer and Madden as a crater, and since 1860 as a small white patch with a central nimbus. Well, I looked into the white patch from 1961, when I recorded it as a crater. And in fact, we now know that it is a crater, and there's a rather lovely picture of it, taken from Apollo 13 actually, and there is Linné, the bold-shaped crater, and that, I think, is a crater that could quite well be an impact crater. I say, in my view, impact has played a rather subsidiary role in the lunar formation, in the lunar genesis, but Linné certainly could be one. It looks like a moon is bold-shaped. I'm sure nothing's happened there for a very, very long time. But now, what other kinds of craters can we find? Let's try some comparisons. Now, that area of the moon you probably don't recognize. Somewhere near the Mare Medium, possibly. In front of that, just faster for myself. And there is another picture showing the Mare Australe area with the crater Ocken down there, and Marius, just a 22 on in that area down there, and there we have the crater chain leading up to the Mare Humorum. That's what it looks like. Actually, that was a picture that I showed at a NASA conference way back in the 1960s. It is a photograph of the top of a saucepan full of boiling coffee. It took me some time to get. So when you have that, and you have a boiling coffee like that, that's a remarkable rumor. So it was Cook, Newton's contemporary, although certainly not friend, who suggested that the lunar craters might be due to vast bubbles. Well, of course, a bubble of that size will be dynamically unstable, but I think when you talk about the upswelling process, and you may be very much more near the mark, and I think the Cook may have been on to something, even though the process couldn't be what he has said. But I show you that because it shows that you can simulate lunar craters in that way. And those who believe that impact is the main process always maintain that you can create lunar-type craters in miniature by firing pellets of bits of stuff, and of course you can do that. My point is you can also do it this way, so it doesn't mean at all. There's another crater. That was one that I built myself. Again, we're Peter Capital, the geologist. We were on the beach down at Dockner, and we wanted to see how the incoming tide would lap away the wall of the crater. So we pursued the middle of the sand very well and photographed it. And when people saw two elderly, one elderly and one fairly young gentleman on their hands and knees, building sand craters and castles and celebrating photographs, they gave the general impression we got army. Nevertheless, it does look slightly lunar, doesn't it? But there's something very different. That again is a picture I took myself. This is not fake. That really does show genuine craters. They are on the moon, haven't been there yet. These are items. And this shows the famous volcano of Virtual, and there's no doubt about that. That was formed by one blast in 1616. And there is the Lunar Crater Thebit, and there you see one of these lava areas. It was remarkable like some of those on the moon. And there's a Virtual also has a very nice central peak. It appears far more lunar and tight in my view, and the Arizona meteor crater does. And there's a rather better view of it. You can see there the central peak and the solar fall. Also, the depth diameter ratio is very much the same as it is for many lunar craters, and quite different from that of the Arizona meteor crater. And there's a picture of the interior of that wall, actually put from the wall, and you can see there, the central peak very nicely. And another view. That's the drunk slide, isn't it? That's the adjoining crater of Lucan, which unlike the Earth, is not got a central peak. But when you see the joining of Lucan and Hiralmbanga, it's very much the same as the way in which Thebit and Thebit A meet, even though the scale is very different. Thebit's 23 miles in diameter, Thebit A is 12, Virtual is about 2, and Lucan 1.5. So the scale is different, but the general overlay is the same. And that is another picture I used some time ago. One of those, again, I took myself. That's one I took myself. That was one of the first pictures ever sent back from the Russian lander, Lunar 9, which came down gently on the moon in 1966 and showed no sign of sinking into dust. And in fact, you can see part of Lunar 9 there, and that built was about 4 feet in diameter, casting a shadow. So that is the scene for Lunar 9, taken from Lunar 9. That's the picture I took myself of Icelandic lava. And I think you'll agree that the two are very alike. And you know, if you go to places like meteor crater, you don't find the word connected. You do find large chunks of meteorite lying around everywhere. And when you go to other proven impact craters, which will speak in Australia as well, who I don't know myself, again you find plenty of material which is undoubtedly meteoritic. You don't find it on the moon. I think it's during the course of the have a good impact, where the meteors from. Here's another interesting structure. I didn't take that one, although I had a hand of zoom taken. It was taken on Gemini 4, and those are the Richard structures in Adon, Mauritania, in French Equatorial Africa. And there again you have a whole series of structures which are concentric and which are almost certainly volcanic. I think in a very dark stuff. And let me come back now to my last two slides. And there again is the Calico. And that white rectangle there is shown a larger scale there, difficult around as an orbital picture. And I say again, we have here a 54-mile crater which come down the very crowded area and must necessarily be the youngest formation anywhere around there that is raised over that everything else. And yet it has no sign at all having broken down obviously smaller pieces nearby it which are covered by its rays. Also the rays are not actually, don't come from central peak at all, they come tangential to the walls. And one of them actually crosses the Marlis surface, going quite close to the famous crater of Septal, that appears to be rejuvenated there. And possibly kind of the end, there is a picture of Apollo 14 leaving the moon. As you see the flags being blown around by the blast from the rocket. And that's the only time the flags have been blown around, because it's not going to live on the moon. And therefore they are now standing just as they were, and there they will stay until someone goes into electrons, and no doubt what happened within the next 20, 30 or 40 years. So where does all this take us? I wandered rather a long way from Thebit, I must say, but I intended to do that because Thebit to me is the very archetype of the kind of formation that we do find upon the moon. It's a splendid case. It does show so clearly the non-random distribution of the craters, how one smaller is not larger every time, or virtually every time, and it also shows that when this happens, there is no obvious area of shaking down. And bearing in mind that the lunar crust is not so rigid as ours, well, can you imagine the devastation if a missile landed somewhere from around here and blasted out a 54-mile crater, there wouldn't be very much left of anything standing close to it. And I feel myself that would happen also on the moon. I am not suggesting for one moment that we go back to explosive volcanism. What I am saying is, in my view, the distribution and the nature of the craters precludes any violent origin. I think it precludes violent impact. I think it precludes violent volcanism. Over in Leicester, Alan Lewis has been making some fascinating experiments. As you know, the fluidized bed. He's been passing liquid under various structures, heating them up, and he's getting remarkably unified results. And in that respect, of course, you could get away with anything explosive. And I believe myself that when we finally come to analyze it all, we're going to find out that the lunar craters were not produced in an explosive way. I think they were in a very more gentle way. And although undoubtedly there must be impact craters upon the moon, that we get them on the Earth, and although there's no doubt at all that the impact of nitrogen fuel that Dr. Wilson was talking about earlier are responsible for what's called lunar gardening and churning up the surface, no doubt about that at all. But I think we can find that the main ones are probably of internal origin. And I think the fact that, in my view anyway, that the seas and the craters are basically of the same type, I think that reinforces this. And I don't know that anyone has quite called attention to that in trying to do, to the fact that in geopolitics we do have the perfect example of a missing link. I admit it's the only one, but there we have a feature that is intermediate in size in a large crater and a small sea. It has a Marley-type floor, a semi-Marley type, part crater-type wall, and a crater-like central formation. So there I think we do have the missing link of the Marley craters. So, and I come back finally once again to the point I made earlier, that although we've got now all these magnificent pictures from the Apollos and the orbiters, we've not got pictures of the entire surface of the moon under all different kinds of illumination. And at the moment, there are no probes monitoring the moon, even those on the surface, unfortunately, switched off. So there are no probes now monitoring the moon. And I think there is a great deal to learn from continuing study from the Earth. And in some respects, of course, actual naked eye work, the telescopic observation of the eye end of the telescope, is even more useful than photography. Photographs, of course, can't lie. And they look much nicer, but they can't show as much fine detail as the keen observer can see at the eye end of a 12 or 15-inch telescope. So I think there is a great deal to be done, and that's why I so very much welcome the reappearance of the moon with you guys, and I think the James are doing a magnificent job at editing it. So when you look at the moon through a telescope, then this is old practice all done by August and Apollo, because it's practice. And although we learned so much more about the moon than we deemed possible only 20 years ago, there's still a great deal we don't know. And I think the people like you and me, sitting with our telescopes, quite apart from things like Lunar Crater, we've still got a lot to learn, and there's still a lot that we can do. And I think that my time is up. May I have a final word, but this is certainly the last time that I shall come to Lancashire and Morecambe as BAO President. My term ends in October. I've been president last 2 years. I've set out to do various things. I hope I managed to do a bit of it, even if I haven't done it very well. One thing I was particularly anxious to do was to take the BAA around the country and bring it to the affiliated societies. And I have been around a great deal on this, and I hope it's done some good. What we have done in some cases, of course, is that people have stopped to join the affiliated societies, not the BAA itself. Well, okay, I realise that this is bound to happen. On the other hand, if the BAA is going to maintain its position as the premier amateur society in Britain, and then it has a strong admixture of professionals as well, then it's got to have members. And if our membership does not stand up, then obviously we can't do the job we're set out to do. So I would make a personal appeal to those who are interested and want to back up astronomy, not only to maintain your membership of your local society, but also actually join the BAA itself. Well, that does help us, and I think we'll find in the long run folks do as well. And also, if there any way we can do to help affiliated societies, then please let us know. I've had so many letters, at least not so many letters as I've been trying to do. When I took over, people said, well, what's the advantage of becoming an affiliated society? What do you do for us? And I say, what do you want us to do? And then they say, well, can you send us speakers? I say, yes, then you want, how do you want? And we do it. So we can't tell the council what the affiliated societies want, and they say let us know. But One associate this was only about one member, and really this is not on. I don't know what the answer is, but I do appeal to those of you who are not members of the VA and are interested in astronomy to become full members as well as joining all over society, because I think in the long run it's going to do everybody what it is. Well, I certainly enjoyed my tour as president. Whether I've been a good president, I don't know, probably not, but I certainly enjoyed it, and I very much hope that our activity is going to be considerably increased under my successor. Again, thank you for inviting me.